All right, hello. Let's get back into this. So let's see. Last time we made a bunch of progress with the binding to an execution. Now there was some fallout from that, which made this basic pipeline broken. So that's what I'm trying to figure out. And during that I added, so I did a little bit of stream here, but not that much. But I started to add, where is that? Whoops. Here we go. So I started to add these things, comments. So I added like a comment instruction. So I mean, it's just to see in the instruction compilation or the compilation result some debug information. So I'm currently adding that in here, and there we go. So we have this these comments on every time we call like some kind of, so we can see where, like which path the compilation took. We can see that now. So we have a comment which states first the kind of expression where this came from, and then what function has been compiled. We might change the order of this later if it looks weird, but that's the idea. So I'm just adding that to whatever compile functions we have, basically. And compile identifier. And as you can see here also, it's very generic. So basically we have this almost everywhere we have a source. Here we actually don't. So I might actually add a source maybe. Because this one is, it is probably helpful to have a source. I'm just looking here if we actually compile it. So because basically this doesn't actually do any compilation, like it doesn't actually produce any output, like any instructions. But now that we have comments, then that is useful to have. So I'm gonna do that. Also, there is an issue actually with doing this, because if we have null, that wouldn't work. But that will be a compiler error, so it's not a big deal. Compile with context. Here we have a source, so we can just use that. Let's see. We probably have a source at most places, so I'm just gonna add this there. Okay, cool. Back here. Compile call. Excellent. Compile expressions. I'm not sure if this is even used anymore. No, so I might remove that, but allocate, and then a bunch of, but here we have compile main closure. We could probably, for this one we could add consume. No, compile with context is probably good to have. Execution call. Yeah, so a good thing about this being generic, you can see we're just pasting it in, because the function name we can get from this. So this is the current function name, so this will result in this string here, and the source we get there. So that will result in which expression, like which part of the source code was this compiled from. We don't really need for main. That's just one thing. This one, no. Compile. Actually, you know what? We could have this one, except it's a pre-instruction. So it starts at the first pre-instruction here. So so this would be a little bit different because we need to do this. And we need to say, well, from, so this is the source, right? So I'm just going to say null here because the comments are usually, yeah, the comments always have like source null that I did for some reason, but let's stick with that. And then we have comment, which is just a string. So the string in this case is this part here. So actually, let's see. Yeah, I mean, it's just going to be comment message is going to be the same thing in here, except this is alloc print allocator, please, and then this part try. No, standard format. There we go. And then this would be the message. All right. But now we need to add one there. Okay. So that should be good for this one. Let me copy this again here. Compile if, sure, if else, if no else, pipeline, block, function declaration, binary, and that's it. Okay, cool. Let's run a build so we can see it compiles. Great. Now I have a new binding here, so I can press F4 to get the compilation result here, so we can inspect it without having to run everything here. But I was inspecting why, because the whole reason. The whole issue here is that when we run this, we get some error, index out of bounds. And what it comes down to is if we run this in the debugger and go up to here, we can see that when we run this one, it's an error because the stack, there's a stack issue. The imbalance here is it's saying that, well, stack address, the relative address 5 does not exist, so there is some issue with the stack relative counter that's happening, and that's what I'm trying to figure out. So so now that we have these comments, we can see that we have the comments here, and we can see that, hey, here's a comment. This is the expression where the comment, or I mean, yeah, where this, yeah, or this is the expression rather, where this is happening. So compile statement. Okay, great. Compile expression. Yes. So this is one statement here. The whole thing is one statement here, and then it's also an expression, the whole thing. And then we compile the pipeline as well. Yeah, and this is the source of the comment instruction, so that's why it says null there. So I just want to see, like, where does the instructions that is following here come from? So these come from compile pipeline, right? And so now we are in, and now we have compile closure, create closure. You can even see this tag or tacked on name here. This is the compiled zig name for this function, specific function, because it's a generic function, so it has like multiple versions. So this is one of the versions. That's why it looks like that, because it has like it has a parameter that has any type, I believe. But we compile, create, closure, and so we get these things. And here's the initialization. There we go. So the problem that was happening was that there was some stack imbalance issues, and I just need to figure out why that is happening. So first thing, let's actually go through this in the debugger so we can see. So the comments don't do anything, we just skip through those. They kind of do something. They actually, what they do is they kind of, it's a no up basically. So maybe I should add, because it doesn't exactly now have the same execution, because this thread will get basically skipped at this point, and then since it's like a round robin execution model, the other threads will get like free turns basically if you compare it to like a game. So that is actually one difference here with the comments, but whatever, it won't really do much of anything. So here we create a pipe, and this pipe is for that's for the pipeline. And now we're creating a closure for the first part, the first stage in the pipeline, which is echo hello. And we create some kind of closure variable here, I believe. And now here's the initialization. So here's the issue, really, because it says compile closure initialization. Well, actually, this is not the issue. Sorry, it will come after. So actually, you know what? I want to add another comment here. I want to add a comment, so compile closure something here. I want to add a comment when we do the pre-instructions, but also the post instructions, because these instructions are kind of wrapping a fork. As you can see here, here's the fork imagined here, and here's the post instructions. So I want to, let's see, we already have the message. We can oops, that was the wrong thing I copied here. This one. So let's do here. Here's the comment. That's the post instructions. And should be the same comment basically. So here is like a marker where we say then, hey, this compile is continuing here, because fork should be wrapped between these. So after the fork, we should get this message. Right. So if we don't, that means there's some issue there. And I believe that was was maybe the issue, that we didn't get the fork before. So and we also need to add one to that capacity. All right. Now let's try this again. So we should see, let's skip ahead a little bit. Here's the first one, I think. Yeah, I believe that should be the first one. And here you can see, here's the second one, compile closure. So there's an issue here, actually, where we don't really see the fork. There should be a fork here. But there's no fork. We just continue with that. So that is weird, actually. That is super strange. Because you can see here we get like an index for the closure to be inserted into, and the post instructions are pasted after the index, or inserted after the index. The pre instructions are inserted before the index or at the index, which will be before that instruction. So essentially we're wrapping one index, like one instruction, with these instructions, but I don't really see that happening. So let's go to compile pipeline. So how this works is basically first you create a closure like this, and this will set the index based on where we are right now. So we have the index, we capture the index where we are right now on the instructions, and then that is like saved here. So and then that is used later when we do the compile closure initialization. We pass this closure in, and that then has the index that we've saved from before, so that we can properly insert those instructions later. Yeah, it's a bit of a yeah, there's a lot. The reason why I'm doing it like this is basically, and not just adding the instructions in directly, is because we don't know which variables are referenced in the instructions that's going in between, well, where this fork is happening. So this fork is using this fork is going into some instruction set, and depending what identifiers are referenced in this set, and we don't know which ones it is yet. So basically we're creating like a marker here and saying that we need to create a closure at this point, but we don't know how many variables there are yet. We don't know how large this closure is going to be, and that gets determined later. And then later we compile, when we know, we will compile the closure instructions and then insert them after the fact. And that is what kind of complicates this a little bit, and we're doing some modifications here that is a little bit not really, yeah, this whole to do here is like saying that we have this relative stack counter, that it gets modified in a special way in the pipeline compilation, and that's not happening anywhere else. And I would like to generalize that to make it so that we don't need to do that, so that it's the same everywhere. But for now, I'm trying to fix this by doing this. And okay. So basically the idea is we create the closure. We have this fork is now supposed to be wrapped with the pre and post instructions. But as you can see, or as we saw, it wasn't actually wrapped at all. So why is that? And this just adds the instruction. Yeah. So there should be a fork instruction in between. That's what I'm trying to say. Because if we compare to this, we can. So this doesn't have a pipeline. So this is compiled with a separate, with a different compilation function. So this is simply a call. And then we're compiling the echo thing, which gets down to an executable call because the identifier is not declared, so it defaults to like we're trying to execute something. And then we just compile the executable call directly here. And this one also has a closure somewhere. Here's a result variable. We have, here's the closure, create closure, and here's the initialization. So here's the pre-fork stuff, and here's the fork, and directly after this, here's the, so this is how it should look. We have a fork, and then we get back to the post instructions here. But for some reason that is not working with the pipeline. So here we have a pipeline instead. We create a pipe. Here's the closure. Here's closure. So here's the first, the pre functions, which basically we set, we save R, the register, and we allocate a closure variable, or we allocate the closure, and then we just continue. So there should, between here, there should be a fork, and I don't understand why there is no fork here. In fact, there is no fork at all. Like down here is a fork. That seems like the fork that should be there up like before. So this is wrong. Yeah, because we pop. Now this closure doesn't exist anymore. So that's where the error is happening. So I don't really understand why this is like this. Like, why is it different? Because it's like at this stage, the fork is the next instructions, right? So it should be the same case. If we go to like compile executable call, which did work, we can see that we should have the same idea. Compile closure, and here's the fork. Now it's a different function, but it essentially just calls fork. And then at some point after we've done all the instructions for the fork, we compile this one, which is then inserted correctly. Yeah, it's the same function. So, all right, let's, maybe we can add some more comments. So compile, create closure, fork. No, yeah, I still don't understand really actually why this is not working. I mean, we might have gotten the wrong index, but that seems like, it seems like there should be some kind of instruction that is wrapping. And we also have the last closure here. Hello, Yishik. What's up? Welcome, welcome. Yeah, and then we have this here. Stage closure. Maybe this is the wrong closure. No, it should be correct. And the last closure, yeah. So this is the one that's adding the things. And it's very important that it happens after this, because this determines which instruction set we're looking at. This is the original, where the pipeline is compiled at. Yeah, I don't know. Closure, create the refs. Here's the pre-instructions. It's basically just saving the register and then allocating the closure, saving that. And then it should, between here, there should be an instruction. Like, I don't understand why there's no instruction here. Like, even if the index is different, like, even if we have a separate index, unless it's like from some other closure initialization. So let's continue here. So we have closure initialization. Hang on. This creates another closure. And then this. So it's like this is happening twice. Hang on. And also, yeah, because these addresses are the same. So it's like happening twice. This one. Okay. And then we store some variable in the closure. Yeah, this looks bad. And then we have the pop and the for, and the for comes over here. And then we also have another one. Okay, yeah, this looks very, very strange. Okay, so the idea with the pipeline is that, you know, it's broken up into stages. This is one stage, this is one stage. In between the pipes, there's something called a stage, a pipeline stage, and each stage can be any kind of expression, really. And it's compiled, but it's also like compiled in a special way. So because any output that this is going to have is then supposed to pipe into standard in over here. So it's compiled with a different context, you can say. Hello, code guy. Yes, I'm continuing with Brunik here. I feel like there's not that much left before we got some an MVP here. So I just want to finish this and yeah, then I can do some other stuff. So this stage will basically we're kind of wrapping standard out in our own like in-memory pipe, and then we're connecting that to standard in of this expression here. And so each stage has to have its own context, and that's why and also on top of that is like we could refer to variables inside here and stuff. So everything needs to be like hooked up correctly, and that's why we have these closures and stuff. Because because each stage in the pipeline is also running like kind of like in an async manner, because it's like streaming the data through the pipeline as well. And so yeah, it looks very simple, but it's extremely complicated. Just this, I mean, when you look at this, it's kind of obvious what's going to happen, right? But to actually do it like in this way here is very complicated. So, well, at least the way I'm doing it, I mean, there might be some other, like some kind of, you know, genius way to very easily, hey, solve it, but I'm trying to solve it like this. Like I have this IR language and I'm trying to make it work here. Anyway, everything is crazy. Cannot understand much, bro. Yeah, same here. I'm trying to add more debugging information. I mean, yeah, this looks, you know, of course, it's a lot of things happening here. Like, you can see that this simple statement here is compiled into all this. Now I added comments to kind of more trying to trace where the compilation is coming from. Like, where are these instructions actually coming from? So you can see it's coming from pipeline. And yeah, I'm trying to debug why this is getting me some error here. And from what I can see now, we get like a bunch of garbage from the pipeline. So there's something going on. There's something wrong with how this compilation is inserting instructions, basically. So this is fine, this part. But then down here, these things are not fine. Well, this one might be fine. This is not happening at this point because we don't have any middle. These only happen for like the middle pipe. Like if we had one more stage, it would go in here and also do the middle ones. Because they are compiled differently, because we have like a standard in from the previous stage and standard out to the next stage, so they are different. And then the last one, it has only standard in, and then standard out is inherited. So, so what we're actually compiling is this part, and also then this part here. Maybe I'm gonna add a comment here to say. Let's do compile so this would be like first stage, and I'm just gonna add this here. So this would be stage I, except it's like +1 because, wait, yeah, it's +1 because the first stage is already, okay, sure, let's have first stage, that stage, blah blah blah, and here's the last stage. Maybe I should actually, no, that's fine, that's fine. It should be before the correct closure, because otherwise the correct closure will wrap this instruction, which is not correct. You know what? No, you don't know what, actually. Or maybe you do know what. No, you don't know what. Okay, anyway. So now we should have last stage, first stage. Let's look at first stage. Okay, here's first stage. Create a closure, initialization, and here's a comment. Yeah. Yeah, here's the post. No, this is another pre. So this comes from somewhere else. And this one. And there's the last stage, create closure. As you can see, the last stage actually doesn't have any closure anywhere here. So we have the fork, we have the refs here, but then the fork comes directly here. So there's something, I think the index is wrong somewhere. Last closure, like this, it seems like this is compiled in a different world, basically. Compile creation. No, this is fine. This one is fine. It's like this one is not fine. Okay, I'll add another comment here and say this is stage closure initialization for stage. But the thing is, this is happening. Yeah, I just want to see which ones are happening here. So let's do format stage closure. I want to say stage I or I. Is that what? Don't we have that? No. And I want to do a format JSON stage closure. Now these include like locations and stuff. Maybe we should just do the index actually, because otherwise it's going to be too much information here. Okay, I'll just do the index. So this will be the instruction address, basically an instruction address for where this is supposed to be inserted here. And maybe, no, that's fine, yeah. There we go. And I will do the same thing over yonder. Here. Except this is now the last closure. So we can see exactly, also this is the last stage. So we can see exactly what index they are referring to. I'm gonna make sure that it's also freshly compiled. All right, so we have first stage. Now where are these comments? Okay, here we can see stage 0. So we don't only have one stage or two stages. Well, we have stage 0 and last stage, so that is good. You can see that stage 0 is compiled at 14. Last stage is compiled at 19. Okay, actually, I just realized something. So there is a slight issue here. Yeah, okay, I just realized. Because I don't understand how this wasn't a problem before. Because I'm pretty sure this did work before. Maybe it didn't, actually, it never worked actually. But the stage closure, so when we do this, we say that, hey, this is the index here. But the idea is that this is going to be wrapped by a bunch of instructions. Now, oh yeah, it worked before because we didn't have closures, right? Now that we have closures, this doesn't work. Okay, I understand. So what is happening is that we really have, this index is actually not the correct index. I mean, this index here is not the correct index because we haven't added the instructions yet. So that is an issue. We actually don't know. We actually don't know the index of these instructions. So what we have to do is kind of modify these stages after the fact to see how many instructions were added. Okay. So the first stage is like the only stage that has the correct index, and then the subsequent ones does not have correct index because we're adding instructions after the fact. Okay. So what we want to do is we want to say before we do this, we want to get the number of instructions is going to be instruction sets, items, current instruction set, instructions, items, length. So that is the number of instructions before this compilation. And then after we have, so this would be after. This is before. Okay. And then we get like the difference. Diff is gonna be after minus before, because it's after is gonna be larger than before. And now we basically need to modify, this is so stupid, but we need to modify all the stage closures that comes after the one we are looking at here. So we need to go like for stage closures I plus 1, I guess. I think, yeah. Yeah. And we need to modify the index to be instruction, so the diff needs to be added on there. Okay, and then actually let's keep a running total here. Okay, so diff is gonna be plus equal this. Okay, and then we don't need to actually do this then. What we do is we do before here, we're gonna say stage closure index. We modify this before, so we only need to modify one each time. And in the end, the diff will be correct for the next closure, hopefully. And let's see what the other one here. So I'm gonna say last closure needs to be modified by the difference that we currently have. Are you a const? Yes, so let's make you a var. There we go. And you are a constant, of course. Let's do this. And this. All right, it's it's a little bit spaghetti here, but hopefully now it's more correct. All right, so here's the first stage. There's the closure, create closure compilation. Here is the first thing here, which now looks more correct. And there's the 4K, and here's the continuation. Yeah, this looks very good here. Save R again. So this one I think is not actually even used here. Yeah. Is that correct? Actually, I want to double check that. So where's the first stage? First stage is over here. Yeah, so this fork is actually not even used, so that's correct. All right, and here's the other closure. This is the last stage here, yeah. And here's the forge. So this one actually didn't actually have any. Well, okay, this looks weird. Actually, this looks off. Oh, you know what? No, wait. Okay, this looks actually off by 1. This one should be down after here. This should be in between. Well, it should be before. Yeah, it should be after this one. Between these two. So there is like an off by 1 here. Why is that? So after the initialization, we should have like pre and post instructions. Those are added. We also have this comment added. So maybe the comment is also should be counted in. Yeah, okay. Actually, yeah. The comment. So where's that? Where was that diff? Okay. Well, actually, we do have the comment of that. No, this one is counted in because it's happening after that. Yeah, we take before, we have comment, and this comment should also included. This is happening. That's the new length. So we should get like how much it was in between. Right? It should be like +1 here, but I don't understand why. Or -1 actually, maybe? Yeah, I think -1. I don't understand why though. And it's like, what happens if we have more? If we have another stage, will it be also even more off? Okay, now we get like a compiler error. Start index is larger than okay. Closure index. Okay, did we get like an overflow? I don't, or underflow or whatever. Before should be less than after. Also, if we got an overflow underflow, this should have been an error because these are U size types. Yeah. That should be like a It should have caught that in Zig. But instead we get this garbage number. Okay, so index, so let's go 1607. Closure index. Eighteen, 16. Stage closure 1 plus equal diff. It's set to 0, so, and then we get like before and after. And diff. So it's like at the second iteration, this is where it gets wrong. I mean, there could be something wrong with the stage closure pointer or something. Yeah, look at this. So stage closure was too fast. Okay, so zero, so that is actually, well, okay. 0. Wait. Oh, this is 0. This should be like +1 though. Is I used for anything else? It's, yeah, this should be 1. Here. Okay, that makes a lot of sense. And now it compiles. Okay, so it was some weird issue like that. Okay, cool. Now let's see if it compiled correctly though. So here's the closure, here's the pre-instructions, there's the fork. Post instructions, very good, very good. Stage 1, the closure, here's the fork. Okay, so it is off by 1 again. Because this should happen after the pre here. It should be between here. Okay, now I want to see if the next one is like off by 2 or something like that. Here's the post instructions. Yeah, wait, no, what? This is the last stage. Hang on. Yeah, this is stage 1. Last stage. we should have the create. Where's create closure? Oh, so this is inserted after. Okay, so we're wrapping this now. That's what we're wrapping here. I see. So it's off by 1. Yeah, that makes sense. Okay, and then we have create closure, fork, closure insertion stage, and we're wrapping something else. Yeah, it's hard to see what we're actually wrapping here, but the fork is here. The other fork was right before the initialization. This is like 2 places before. So, I mean, maybe we just need to like -1 the difference. I don't really understand why. But it seems to be like off by 1 error. Okay, fork is good. Set fork. Yes. Post. Yeah. Okay, now it's aligned. Okay, let's just go with that. Does it work? Unsupported waiting. Okay, so we got some other error now. I'm gonna remove all these. There's a quicker way to do that, but all right. So we got unsupported waiting. So where is this happening at? $4.25. Breakpoint and IR 425. Okay. The weighty is address 10. Thread 6. Okay, so I guess it should be like dereferenced here. But where's this coming from? We can't really see all instructions here, so I guess we'll inspect set number 4 in this view. Executable call. Again, we have a closure at some point here. Closure initialization. Yeah, this is pre-instructions. Here's the fork and the post. Yeah, that looks correct. Now, what is happening here is that the result of this fork is supposed to be a execution handle type that we get. So maybe, and that is supposed to be handled by the evaluator, I believe. If it's not, we get this unsupported wait T. We resolve a location, which will give us the value or another pointer. We're looking at this, if it's thread, closable. I mean, we could also do this in the compilation and not do it in the evaluator as well. So we would like hook this up. All right. Yeah, my brain kind of wandered off there a little bit. What are we doing? Sorry. Oh yeah. Now I remember. So compiler. Please go back. Thank you. Compiler. So compile. Okay, I just want to know, where does the weight come from? This is the this is set 4, yeah. Was it 10 or 30 or 20? No? 37? $25, that's 37. Yeah, okay. I should really make these should be like hexadecimal so that it's the same everywhere. I'm just gonna change that real quick. So we have like, where is this actually coming from? Something verbose. Log, right. I don't remember where we do this. It's the runner, yeah. Compile. Here we go. Struct types, instructions. Set log instruction. Here we go. So I'm gonna change you to X. And there we go. Now we have hex. So back here. So now we get the same number here. 25. Okay. Now, yeah, so this is happening. Where is this happening? And then we have like pipe options after. So compile, execute a call, was it, I believe? And we have pop. No, it's in this part here. Yeah, here, I think this is the weight. Yeah, this is the weight. So wait. No, this. Push or pop. So this saves R basically. What is R? R is this pop, which should be this, the thread handle. And we set that to R, which is this pop here. which again then is this, the closure. No, it's not. Okay, sorry. It's two pops. Two pops. Pop pop. Pop pop. So this, it's not this one. It's... I'm confused. This pushes. So we actually have like 3 pops after this. Oh man, this doesn't feel like it's balanced here. Where are these pops coming from? Thread handle. Okay, I think this is just used for us to be able to say to store. Yeah, we're trying to save the thread handle, which is R, which is like, let's look at this one here. So pop pop, it should be the closure saved R, because we have the ref closure refs. Yeah, so it's closure saved R. So that is whatever R was before over. No. Yeah, it's from the fork. So it's the fork here. So this should be the fork. This should be the thread handle. So that should be correct. Okay. And then we're using like the execution handles pointer to be able to set the thread handle on that struct, the execution handles. And then we do 2 pops. And that is where I don't really understand. Why is this last pop? Is that like the pop that before all this? There's a push over here somewhere. This one, execution. Okay, so we're popping the execution handles. And we're pushing that. And then we're popping. And then we're waiting for that. But it's not dereferenced though. Should be dereferenced. Typed dereference. Actually, then it's not actually typed like that. You know what? And then the thing that actually takes this which is here, statement, and that it looks for, okay, is this waitable? It's looking at, okay, is this a execution handle struct type, register? It could be something else. You know what? These are the same. So actually, we could just, we don't actually need to switch here. We can just say if. We can just do this directly, because it's the same. I'm pretty sure. And it should be dereferenced, so I'm not sure why that is happening. I'm gonna add a comment here saying wait from source function name, so we can see that it's actually this that is happening. No, it's not. So where's this wait coming from? Could be that, I guess. Oh, hang on. It's probably this one. What is IR? These are logs. Are you building a shell or a shell language? I'm not building a shell. I'm building a, well, I mean, I kind of building like a, I guess you could call it like a semi-shell. I don't know. It is like a virtual machine that runs these things in it, but it's not, the idea of it is not to have like an encompassing thing that you run a shell in. It's more like you just run these scripts, one-off scripts basically, but the scripts are run in, I guess, a shell-like environment. But it's not supposed to be like you can run like a bunch of commands in one shell. You just write a script. It's a scripting language. You just run. Think of it as maybe like Python, except it looks more like Bash. So you just run the thing directly. IR means intermediate representation. So, well, the idea is that, whoops. The idea is that, well, this is the actual scripting language. And then over here is the, so we compile to another language that looks a little bit more like assembly code, basically. It's a flat list of instructions that do, you know, things in like, and then it has like context. So you have things like a register, for example, and that is just, it's not a real register. It's just a way to have some kind of context that we're running in. And the whole purpose of this is to be able to stop at any point, stop execution, let's say at this point. And then you step through and you don't lose any context, you don't lose any anything like that. It's easy to just stop and continue running. And we're using that to be able to have async operations and stream data from one command to another without having to have. Well, yeah, it enables that kind of behavior. So yeah, that's what's happening. Basically, this is compiled to this language over here, and then this language is what actually gets executed with the evaluator, with this, like the interpreter. And also, maybe what you could do later also is like you can make. So usually when a programming language does this, the goal is to compile down to assembly code easier. Like you have a step in between. That's why it's called intermediate representation. So you have the high level language, and then you compile down to an IR language, which is closer to assembly code, but it's not actually assembly code. But it's easier to compile from that language down to assembly code, and that way you can get like a native code, like a native executable in the operating system. But I'm not going to do that. I'm just going to have this IR as a way to kind of make the execution happen in a way that I want to have. Because of how I want the I want to have like the bash like pipes and stuff. So this is my solution here. I'm not sure how bash does it, but I'm doing it without looking at anything else, basically. So yeah, it's a fun experience because I've never done like an IR language before. Yeah, no problem. I'm just trying to figure out where this weight is coming from right now. And well, okay, well, it's probably coming from here then. I'm gonna make a comment here. No. Okay, well, this weight is from there. Set 4, okay. So let's go from the start. Where is fork 4 is happening here? Where is this coming from? This is coming from pipeline. Oh, it's coming from pipeline. I see. Compile pipeline. Yeah, I guess you could call it bytecode, maybe. I guess one difference is that bytecode is usually used to have, like, you compile to bytecode, then you have. I mean, it's not really a huge difference. The difference is that bytecode, I think, is usually you compile to bytecode, and then you have the bytecode in a file somewhere, and that's the kind of executable, quote unquote, that you run with the interpreter. Like Java, you have these, you have the bytecode as files. Well, while here we compile every time you run the program, every time you run the script, we do the compilation and then interpret the results. So we compile every time you run the script, the source code, it compiles. So there's no like intermediate compilation step and then we run it like later. We run it immediately. Although technically we probably could, you know, make it so that you could compile it and now you skip the compilation step, but that's not really the way it's supposed to be used. It's basically just supposed to be used as a bash script, but you run it with this interpreter instead of bash. And this is just how we internally, you know, prepare it for being able to run, or yeah. But we do it all in one go. I mean, I think Java, for example, there's probably a way to run a Java file directly, sort of like a scripting language. I mean, you could compile it first and then run it, but I'm pretty sure you're always, or yeah, you're like compiling it to an intermediate representation or a bytecode, and then have those as files and then run those later. So you're parsing and then transforming and then run yourself. Yes. I mean that. So to make it to be extremely clear, you have this source code here. So when we run when you run Runic on this, like you run the executable like this. Well, now it won't work because I'm working on this, but let's do like basic. This will work, I believe, hopefully. Yeah. So when you run this, it's compiling it and then interpreting the compilation result. So yes, we are parsing the source code, we're transforming it or compiling it to an IR, and then we're interpreting the IR, and that's the output that you see here. So all of those steps are happening when you run this. All right, let's see where this weight is coming from. So we have, so it's probably this one. I'm gonna add a comment here now. Do we have any other weights in here? Yes, we do. We have this one. So let's add this one as well. I believe this would be the last stage. No, this is the, wait. This is in the set. This is after the for loop. Right, this is the last stage, I mean. So this would be wait from this last stage. And that's it, okay. Alright, thanks. Are you a developer? I mean, I guess you are, since you know a lot about this. Okay, yeah, so wait. This is set 4. Okay, so this is from compile. So this is the intermediate. Okay, so this is from within the set. Right. All right. Okay. So let's do this also here. even though we know it's waitable. We do this so that we get the correct compilation of the what we are supposed to wait for. And we have to convert it. Okay, so it didn't get awaitable at this point. That's weird. Now, it should. I'm pretty sure. Okay, hang on. The result is waitable. We push that, we fork, which we don't care about. Then we pop the source. That should be waitable. This should be like, what are you returning? Oh, I see, we're losing the type information. I see. That makes sense because it's hard to know what we're popping here. That is just that's runtime known. However, we kind of do know, since we're waiting. We know it's waitable, but we don't actually get the thing here that we're supposed to wait for. And we're doing this because fork inherit overwrites the register. So we're pushing to make sure that we save the thing. I'm just gonna do this. I'm gonna get this and we pop and I'm gonna overwrite the type. And then we don't do this because we know it's waitable. And now we can wait for that because now it's typed. Wait, no. No, that doesn't work. Actually, no. We do this because this kind of sort of compiles it again. So I'm gonna do this. Well, it doesn't compile it. It kind of modifies the pointer to have it more correct. Okay. So now we should see a wait over here. There we go. There we go. Now it's correct. I also tried to make a shell-like program in Go via code crafters. I don't know what that is. Code crafters. What is that? But looking at your code, I realized I just hacked my way out. I mean, that's all programming is, basically. You're hacking. You can always make it more. I mean, this is probably unnecessarily complex for what I'm trying to do. Like, I just don't see. Yeah. I made it. First, I made it without an IR, and then I encountered like a roadblock, and this was kind of the way forward that I was seeing, but it required almost like remaking the whole language basically in IR. So I mean, I kind of questioned my sanity for doing that. So but it is a very it's a very how you say it, it's an experience that I'm learning from. That's what I'm trying to say. Okay, so if we run this, we get, oh shit, we get like an infinite loop or something. No? Okay, so let's see what's happening here. We're stuck on wait for this. Okay. So that is 9-9. Okay, so let's see what's happening here. Threads. We have thread 11 and 7. Okay, so the main thread has exited at this point. Interesting. So that's kind of weird, because it's supposed to wait for the pipeline to finish. Roadblock with closures and async stuff. Yeah, I mean it was like a combination of. So I did have streaming pipelines, but the issue was that if you had a block of code, like a blocks like this here, you had a block. And never mind this parenthesis syntax, it's just to make the block work as an expression here. So it's not the subshell or anything. So basically you have a block of these things. Now this could be a block in an if, or it could be okay, never mind. It's just a block of code. This is run like in kind of like a sub context. So everything is in here is like being outputted to the block pipes, you could say. And if you pipe this into something else, how do we actually execute this? Well, the thing is, like, when we're in the block, we want to execute this and wait for this, and then continue down here and wait for that, and so on and so on and so on. However, we don't want to wait for the whole block to continue to execute. We want to be able to stream the output into the next stage in the pipeline, which is this grep here. So that means that we need to, when we're waiting for this to output, we also want to stream the output back like out here. So we have two kind of execution contexts. One is the block here, and one is this part where we stream data in here. And that I was having a lot of trouble, like I knew kind of what we had to do in order to make this work when I had without the IR. But basically it was something like you had to be able to stop execution in the block and wait for a thing, and at the same time streaming out here. So then I was like, well, if I make an IR that has like a list of instructions with a context, a virtual machine and all that, then it's very easy to stop it's very easy to just stop the execution of one thread, but also have like parallel threads that just keep going. So that was my solution to this issue. This is why I made the IR. This is like the thing. Can I use Runner right now as a replacement for Bash? Not really. And it's never going to be a full replacement for Bash. Like it's not going to have all the features of Bash. Like right now, what the goal is for the MVP is so it's not even like you could do very basic things right now, but and you could do everything that is in the MVP here. This is like you can do everything in here, but there are some things that are not like very implemented, like functions with pipelines is not supported with this previous version here. I'm working on making that work, but basically everything that's happening in this file you can do right now with the version that is like on main right now or master. But you know, there's a lot of things that Bash can do that Runic can't do. So, but if you look at this file, you get a basic idea of what you can do in Runic right now. And I mean, things that are kind of missing also that is like super useful is like getting maybe like a process ID, figuring out if a command is. I'm not sure if actually you can have a failed command right now. I like if you're saying if, and you're trying to figure out if a command has failed or not. I don't remember if we actually have that right now. But I'm working on a new version that like completely changes how the language works like underneath the hood, so that we can do more complex things. And that is taking like a lot of time. But yeah, hopefully I can get it like an MVP version out soon. Where were I? Yeah, so this was the reason why I needed to do an IR version here. This kind of expression here. Well, needed to do. I mean, this was my solution was to make an IR, and I was thinking like at the time I was thinking like, hey, it shouldn't be that complicated, but it turned out to be very time-consuming and complicated, but also fun and very much learning experience. I don't really speak English, sorry. But yeah, now I'm trying to, so this has worked before, I'm trying to make it work again now that we have closures basically, and so something is going wrong here, and maybe I should try to just run this thing from the start. The problem with this is also like there's like when you compile to IR, there's so many instructions that you have to go through. It's a little bit hard to debug. Also, the debugger wouldn't be, well, it basically wouldn't be possible in the older version as well. Like if you have an IR or compile to assembly, of course, it's super easy to make it a debugger, because you can just stop at any moment. You can have a step function and all that. Why stop middle of the block? Just fork, execute, and feed for pipes. Yeah, the thing is like, how do you do that? The issue that I had was that, you know, how is this actually happening? Like it looks simple on the surface, but when you dive down into it and you spawn the process up and you create the pipes and all that, like, and then you also have to kind of wait for this to complete. You have to wait for this to complete. You have to wait, but at the same time, you also have to continue down here. Also, how do you solve the problem with like async stuff? I mean, there might be some way you could use the internal like Linux pipes to automatically connect them, but that won't work if we have something like from the language itself that wants to output something to a pipe. So let's say I want to have a feature that you can say like you just have a string that pipes into something else, let's say. How would you do this? Because you would need something that turns this like into a pipe, and you have to push data into it and all that. So the whole idea is that I want to have a more, I guess, abstract way of looking at pipes. And so I made my own thing that I have to manage myself. I have like full control over this. So I can make anything into something that pushes data or consumes data or something like that. Also, like if you have a function, let's say we have a function, actually I forgot how this, there we go. Function that takes a string called parseInt, and we return a string. So this is how the syntax looks, because a function is basically like an executable process as well. It's the same in Bash, where a function can take data in, it can take parameters, but it also has an output. So it has an input and an output, the same as, you know, standard in, standard out. That's what it is, except it's typed. So, well, actually this would be int here. Also, these types are probably streams, but I haven't fully figured this out yet. But they are gonna be, you know, every function is, you know, potentially get a stream of strings, and you get a stream of ints out for every function that we have. So this would be, you know, some kind of, I don't know, I'm not sure about the implementation. It's probably gonna be some kind of native thing, but it's gonna, you know, this is probably gonna exist in some standard native library or something like that. But the idea is that you would be able to connect this to something it puts in here, and you're going to be able to use that in here. Like you have, like, I don't know exactly how it's going to look, but you could do standard in pipes to, you know, native parseInt, you know, standard out. You know, something like this. I mean, in Bash you would do you know, something like this, I think. And well, this is really a moot. I think this is just, you know, we're redirecting one into standard out. But basically you just have to do this basically. And then standard in, you know, it's also, I believe it's something like you have 0, something like this, or is it this? I forget. But anyway, yeah, just you're connecting these things, and it's useful for us if we can like have full control over this, especially like with async as well. So you stop execution. Well, yeah, anyway, this, and as I said like many times, there might be some other like genius solution to this issue, but this was my idea to do this. And it might be the stupidest idea, but I don't know, it is fun because it does allow me to explore what it is to also create this IR, so it's not like in vain. It might be not the most optimal solution, but hey, I think it's pretty cool to do it this way anyway. But yeah, so if I also explain like why stop in the middle, is like we don't want to continue executing these echoes before this is done, because this, you know, what if you have something that does some other side effect, like remove, you know, something like this, remove this, and then you have some logic that requires this to be empty or to be removed. I mean, if we just continue before this is done, then that side effect has not happened yet. But you're relying on the side effect over here happening before you go down and execute the next things, right? So we have to wait for this before we continue. That's just how it is. Unless you do something like this, you do, you know, you do this, which will turn it into a coroutine or a background process, whatever you want to call it. And then it won't be guaranteed that this has finished before we continue down. So now we do continue down. So you have the choice of waiting or not waiting for the thing. Just like in Bash, it's the same how it works in Bash. So that's why I wanted, like, I want it to work like Bash works for these things, because otherwise it would be probably super confusing. And it is very good the way Bash does it, I guess. It's good if it's the same, so that if you want to transition to this language, you don't have to learn it. Basically, the things you have to learn should mostly be some of the syntax, basically, like a daemon. Well, yeah, sort of. You can spawn anything like in a background process in Bash, basically. And it's gonna be the same here, except if it's run in a script, the script is gonna, I'm pretty sure this, I think I did test this. Did I test this here? So basically, if you have like echo hello, of course that is run, and then we quit, right? So if we run this in Bash, what did I call it? Async. You get async hello. The Bash process stops. However, if you run something that is not stopping, so let's test this first. This should not stop, okay? But if I stop it myself, it stops, right? What if you run it in a background process? Will that exit the script? Like, will you get back? You don't. So it actually, if you have a process spawned within here that has not like exited, I guess like a process that Bash like has like control over, or whatever you can say, then it also doesn't stop the script. What if we do this and we do like, okay, I have a bunch of these. So they maybe it's still there. I don't know, but we'll figure it out. But basically that is also the idea there. But yeah, back to this here. Where are we now? So I'm curious as to why the main is exiting. Actually, you know what? Let's do this. Let's go over here and we'll look at when we are exiting. So here's the exit, and here is a fork for set 6. And create closure last. Okay, this is the last stage. So I think the idea is that we actually have to wait. We are supposed to wait for this last stage here. So maybe we're returning like the wrong type or something. Yeah, okay. I think I know what the issue is. So we'll go to, well, there might be other issues as well, but let's go to pipeline. Well, no, compile pipeline. So the thing that we return here has to be, yeah, is the last fork handle fork. Yeah, this is not enough. Actually, this should be like, we should have a type here, sort of. It should actually be some kind of type that we return here, to be honest. Like, it should be a thread handle. I don't think we actually have that as a type right now. But it should be its own type. Yeah, so I'm just gonna add that here. So thread, is that just a, yeah, that's a primitive type. That's just a number basically. It's a thread handle. So actually these could be threads now. Whatever, I'll change that later. Change to proper types. Okay, so yeah. Okay, so this would be thread. Actually, global, right? No? I thought we had like a global thing. I'm just gonna add this here. Global. So basically, something that doesn't have, something that is a primitive type, and it's like it's not defined anywhere. You can have it as a global. I'm gonna say it could be defined somewhere though. It could be defined in the like precursor. What do you call it? Precursor. Anyway, global. So what we have here is a tag, and this tag is gonna be like, you know, tag of this. And we're gonna give you this, where this is this type here. It's the type expression type. So it's a union enum, which means you can get a tag out, and then we would just return. Actually, you need like union init. Also, I'm gonna say this is comp time, so that we don't get some weird issues with that. The union is this. The tag name is tag name of tag. And then the init expression is just gonna be .span global. Pretty sure that's a thing. Yeah, dot global, there we go. All right. Okay, what is happening now? if we remove this, we still get some error here. Okay, so we simply need to add a format function here. Okay. I'm just gonna copy something here. Okay, so it's gonna be like writer write primitive all right. Oh yeah, so we added a thread type. Right, that's right, that's right. The thread type, no, it doesn't have member access capabilities. Type assignment. Oh yeah, this is the type checker, right? Yeah. All right, that was a long time ago since I've been here. So type checker. Validate type assignment. So let's see. I mean, the thread type, I'm not even sure if we're ever gonna like have it here, but I guess we'll do kind of the same thing here. Actually, you know what? I'm just gonna say that it's not really used. So I will just do this. Actually, thread is unreachable. I'll just do this to denote that, hey, we shouldn't actually be able to use a thread type as a... It's like an internal kind of type that's not really used like by the user. Don't forget to flush, yeah. Exactly. All right, let's remove this crap. All right, so now we have this thread type that we can use. So actually, I'm gonna add this as a thing here. Thread type. Global thread. There we go. Because then it's easier for us to compare that. Because that's what we are gonna do. Now, I believe it was pipeline we looked at. And this thing was returned from fork, which now returns a typed expression. So we return this from the pipeline, and then compile statement is looking at this return result and looking if it's waitable. Now, if we look at how this looks right now, we can see that at the end of the main thread, well, we don't actually have a wait anywhere. So we don't see anything. So basically this function is looking at this and saying, hey, this is not the correct type, so we don't actually have anything here. However, we're gonna do another if here is type thread. Then we do the reference as well, otherwise null. Okay, so we're gonna support the thread type here, or yeah, type, there we go. And now we should, whoops, we should see, yeah, we got some other error there, but let's just see if we get the weight here. So there we go. Now we have the weight, which is dereference as well. I'm not sure if we are supposed to dereference this. I don't think so, because it was actually returned as a thread itself. So I think actually we don't dereference. There we go. So does this work now? No? Well, okay. Now we get the hello, but we're hanging for some reason. So where are we hanging? We're not hanging. What? Strange. So we're not hanging when we do the debug, but we're hanging when we just run it. Which one is this? IR pipeline basic. Okay. Interesting. That is strange. Very strange. Is it a race condition? Like here it's just exiting. Here it's fine. Did we get the hello somewhere? Maybe there we go. There's the hello. Weird. Okay, well, let's do verbose. What? Okay, so when we do verbose, it actually ends. But not when we don't. Okay, I'm almost tempted to just ask AI to investigate this, because this is but that's basically giving up. There's a weird difference between doing it verbose or not. So all right, I'm gonna try and figure this out, and then I have to eat some lunch. But we're almost there. Like, we're on the cusp now. So I mean, the only difference is that we're logging this out. What if no, we're running, yeah. Okay, verbose. Hang on. So this is the evaluator. It has also the verbose option, and the only thing it affects is the log. Which the only thing it does is logs to the thing. I mean, okay, there could be a race condition. There could be a race condition that, like, when you have logging enabled, it slightly changes the timing of things so that something is different. Maybe. But that seems far-fetched because I'm not really... Well, the only kind of, you know, async stuff that's actually happening is the thread or is the child process. There could be a race condition. Yeah, okay. So one race condition is that could happen. Maybe, because I have not looked at this for a while, but when we do the executable call, we create this execution handles struct, which is like, it's supposed to have two things: the thread handle and the the process handle. The thread handle is the thread that is executing the process. The process handle, of course, is the process handle itself. But the way it's populated is that the thread gets started, and in the thread, the process handle is then populated from within the thread, and then from outside. Actually, what we're waiting on is the thread handle, I think. This is an executable call. Okay, let's do this. Compile executable call. So here's the execution handle, and the struct has two things. So we're allocating two things. We're setting this to be the pointer that we get from alloc. So this is now pointing to the heap where this struct lives, and then we have a bunch of compilation things happening. Also, we have this result variable. That's right. That is correct as well. We're setting. Oh yeah, so we're allocating the variable here, the mutable variable, on the heap. We're populating that with the pointer to execution handles as well, so that the thread from within can actually use this variable to set that. That's the idea here, and then we populate the closure with that. And here's the closure. We're also copying over that pointer there, so the thread then can access that. That happens in 7. So let's jump to set 7. Oops, set 7. And this one is somewhere we are setting here. So we're grabbing the pointer that we got from the closure. So this should point to the execution handles, and then we're setting the second element in that struct to be the execution handle value, which is the which comes from exec here. So that gives us the process handle in R, and we're storing that in this ref here, and then we're using that to store on the thing. So that all looks great. And here we're waiting for that execution handle. Okay. And then, but before that even happens, we continue down here, of course, because fork does not like run it and then we wait for it. We continue. And now this is the set, the thread handle. R is now stored because fork sets R to be the thread handle that we get from the fork. So this is now stored in this variable. Then we're popping a bunch of stuff. This pop should be the saved R. and we store that in another thread and in another variable called thread handle. So we're storing that there, and then we are getting the pointer back to the execution handles, and we're setting the first element now to be the thread handle so we can use it later. Then we pop off the thread handle, and I think this is the execution handles, yeah. And then we push that again. This is like very highly unoptimized because, you know, there's no optimizations yet in this. I don't think it's ever gonna be. We'll see though. But yeah, we push R to save it. Then we fork something else. This just inherits, and then H0. That's basically null. That's heap for heap 0, and then fork 2. That is just streaming the contact, yeah. So we're just streaming standard out, I believe, or is it standard error actually? Okay, anyway, and then we pop this R here, which is the thread handle, or it's the execution handles, I mean, and we're waiting for that. Now this is the thread handle. This one here is dereferencing R. R is the execution handles pointer. Dereferencing will get us the first element. That is the thread handle, which we are waiting on. And once the thread is done, we set the pipe to keep open 1, and 1 is actually false in bash land, so it means false. This though is, yeah, this means that after the thread is done, the pipe can go ahead and be closed whenever it's done, which will cause it to close properly. Okay, so this one was set for. Did I look at the wrong thing here? Well, okay. Fork 7. Fork 4, the R is in here, is later also in R at this point. We save it again. Restore it. It's not used here. We save. Okay, we're saving this R. Okay, so this fork is saved here, but I don't think it's ever used. Yeah, the first stage, yeah, compile pipeline. The first stage, yeah, the fork is not used, so that's fine. That's how it's supposed. I believe it's the last stage that is actually used to be waited for. Yeah, this is the last fork handle. This is the one that's actually used. So set 4 is actually never waited for. But that's fine because we are spawning all the stages. We're spawning them even though they have not completed yet. Like we're spawning everything here. We're spawning first. We're spawning this. Bash actually does it the other way around. It spawns this first. But we are spawning this first. and then this, and then this at the same time, basically. Well, it's a for loop, basically. And then we're connecting them up. Well, we're connecting them up at the same time, basically. But so we're not really waiting for this or this, but we're waiting for the last one, because that's gonna close whenever this is closing whenever the standard in closes here. So the standard in closes when this is done, and the same thing here is recursive. So this closes whenever this closes, and so on. So this, because this just outputs hello and then closes, right? So this gets hello, and then the source closes. So this just outputs hello and then closes. Same thing here, right? So we just have to wait for this last one to close, and then we can continue execution, right? So that is what's supposed to happen. I mean, I guess that is what is actually happening when we run it in the debug mode. But when we're doing... okay, you know what? Let's just run this in debugger and see. And try to figure out what is happening. Here's the pipe for the pipeline. The first pipe. Here's the second pipe. Maybe we should name them like pipe 1, pipe, like what the actual index is. First stage, yes. Very good, very good. And there's the fork, so now we have that. Pop. Like the bottom line is there shouldn't be any race conditions. We should try to eliminate all the race conditions. There's execution handles for that. Alloc to that is the execution handles, yes. So we're jumping between thread 0 and 4 now. That is the closure. Here's the closure for something. Execution handles is set there. So we can actually look at the execution handles now, because the execution handles is stack +4 on thread 4, which is here. It's stored here. So if you look at heap 10, we can see it's empty right now. These two are the values of the struct. But C plus 0 equals R. So C plus 0 is F. Heap F. F is also empty, okay. Okay, now we're forking pipe, 2 pipes. Yeah, this is the intermediate. This is the intermediate cat. There. Stuff is happening. Comment. A lot of comments. There's the pop. So this is thread 5, yeah. So that is basically thrown away as well. Here we're setting, yeah, we allocated the closure, set that. Ref execution handles. Yeah, so now the thread 5's execution handles is created there. We're setting the closure, we're populating closure with something there. We're allocating execution handles. We are creating a closure again. Set R equals, right, we're restoring R. Now here we are, saving, we're setting execution handles variable to wherever the pointer was there. Closure, we're creating the closure. And now we're forking into 7. So 7 would be, I believe, hello? What? Hello? That's a weird span. Comment echo hello. That should not be its own thing, its own fork. That's weird. Not sure why that is happening. Or it might be something wrong with the span. It might be that the source is badly, because it just looks like the it actually just looks like the execution thread here, because we're pushing a bunch of strings which is preparing for an like a process execution with the arguments. Yeah, so here's like we're pushing the arguments. First is the first argument. This is echo. We're pushing 1 to push the number of arguments, excluding the executable name. So now we're executing the first stage, that is echo hello. But it's, you know, it has to process a little bit before it's actually doing anything. But typically, from what I've seen, I have to wait like 6 iterations before it actually outputs anything. I guess it depends. Set. Okay, I kind of lost on what's happening with the other things. And here you can see exec handle set to R. So exec handle R, you can see up here, closable 0, that's basically the process handle 0. And we are saving R there. Pop. Comment, comment, comment. Here we're popping something. Setting R to be C plus 0. Okay. Thread 6 sets R plus 1 exec handle. Right, now we're populating the exec handle there. I don't think we actually use it right now, so it doesn't really matter that much, but there you go. Comment cat, compile executable call. Yeah, comment, comment. Now we're forking some kind of streaming there. Thread 5 set closure. Okay, so we've created a closure, we're setting that. Execution handles. Hang on. So threads, we can actually say skip thread 8, so we don't have to go through that. Pop. Yeah, pop that Okay, you're now waiting for exec handle SF plus 4. We can see here is the closable 0. So it's waiting for this process, which should be the echo process. Because the others haven't spawned yet. 0 is the first one to spawn. It doesn't necessarily have to be that way, but I think that's the case. Just because of how long it takes. Here's another one. Wait, no, it's the same one. Yeah. So basically, wait. If you wait for an execution like a process handle in this virtual, or yeah, in the debugger here, it basically it's stuck on this wait, so it doesn't continue. But if a thread is waiting, if you're waiting for another thread, then the thread itself goes into like a sleeping mode, and it's considered inactive until the thread that it's waiting for has closed, and then it continues. So we're gonna see that wait over and over. Comment. Now we're waiting on 10, which is what? Thread 6. Okay. Go ahead and do that. Fork 8. Alright, so now we're forking again. Maybe this is the second stage. It's the first cat here. Yeah. Great. Yeah, it's executing here. It's executing cat here. No arguments, just the cat string. And we're waiting for thread number 7. So 7 then. Thread 7. Looking at threads. Thread 7 is set 6. So we're waiting for thread or set 6 to complete, which should be the second cat, which still is like trying to do something here. So the main thread is now waiting for that. We can see thread 0 is now inactive. It's waiting for thread 7 there. I'm just trying to figure out if there's any race conditions happening. Like if something happened too fast, was that going to be a problem? It's strange because these things should happen in the same sequence. The only thing that I could think of is if the executables take too long to do whatever they need to do, and that causes some kind of like pipe to be kept open or something like that. So maybe that could be one thing. Now this one, thread 4, is actually ending here, I believe. Yeah. Thread 5 is still going. Now we're executing the last, I believe, last cat here. We're spawning that up, I should say. This one we could skip. I believe I already skip thread 8 should be skipped, so I'm not sure why that is showing there. It's a bug in the debugger. 5 executing. Here's thread 9. You're still okay, so you're now setting up for the execution after the execution, or after a spawn. So 8 or thread 7 and okay, I'm confused. 5, 6, no, 5, 7, and 9 are the ones executing now. It's weird. Sometimes it's skipping. Okay, you know what? I'm gonna turn this off because it doesn't really work that well. I'm not sure. It's like skipping some in a weird way. It looks like. Now it goes to thread 9. Thread 7. Okay. And 5. So I believe the main thread was waiting for thread 7. Seven is still creating a closure here. Okay, now you're waiting for that. Okay, we got another fork. Okay, this is the last one, I think. Yeah, okay. This is the last cat. 9 is done. Now 11 is a new thing. Yeah, this is just executing cat again. Pipe option keep open, yeah. So we're saying that 11 still doing that. You are doing things. You are done. You are spawning now. 10 is streaming, yeah. Okay. Okay, you're preparing to store the exec handle. And we're setting that. You're storing the thread handle. Yes, thread 11. You are preparing to save the exec handle in the closure. Okay, you're preparing to save the thread handle. You are now storing the exec handle. Great. You are storing the thread handle. So actually now if we look at 1A, here's the execution handle struct. So the first is thread 11 and closable 2. So that looks correct. And then we have a wait. And then we're waiting for the execution handle. Close 4, which is closable 2. So that is correct. Pop. Oh, it's already done. Okay. Comment wait from compile pipeline. You're waiting for thread 11 now. And then you're done immediately. And now thread 0 is done. Okay. Riveting. All right, so yeah. I mean, a lot of things to have to keep in mind there at the same time, it feels like. So, yeah, as I said, like, I think what could be happening is the execution is too, like, yeah, there's a race condition. If, like, an executable is maybe completed before we... No, after it should be, because yeah, the execution is too slow now because we're fast, because we're not logging. So the execution is slow. So keep open is true means the pipes are kept open until they need to be closed. It could be yeah, and then so they are kept open here, but then down where we do the things, we're waiting for the stage to complete, and then we set this to false so that the pipe can close, because when it closes it also closes the next stage and so on. And then the last stage is the one we actually want to wait for in the main thread, sort of here. Actually, we're not doing it. We're doing it in the last stage thread, yeah. So we're waiting for that, but then we're returning the thread so that can be waited on. So it's like it. So it looks like the we do get the output, right? We get the output, but something is not closing. And I'm not sure how to debug this, because when you debug or when you put verbose, it doesn't it just works. So obviously there's a race condition, but I'm not sure when or how it happens. And that's the tricky part with race conditions. Is how to debug it, because it like depends on if you're debugging it or not. So you just have to try and trick it somehow, figure out how to what is the issue by analyzing instead. We could, well, like an idea is to maybe try to wait until after we've gotten some output and then try to figure out what is the state of things now. Like, for example, do we ever reach main thread end? Is there some like in some, like are we waiting for something? Has the main thread exited, basically? That does change the code, so it does change like the timing a little bit, so it could be different, which is also an issue. Also, if we added this would also change things. So I would want to get like some kind of if here somewhere. The main thread is going to be thread 0. We step, we catch, otherwise we get a result with exit success means we ran it. This is a while, that's right. So a while this, you get a result out. We switch on that. If it's continue, we do this. So what I'm gonna do is I'm gonna say if threads and you are a list, so it's gonna be the first thread. The thing is, these threads are not in a hash map, so if the thread 0 gets removed, we don't really know. Get thread context. Okay, let's try that. We get the thread context of 0. If we have it, we get the main thread here. 0 is like the main thread. Okay. If we don't have it, we'll say no main thread. And that's gonna spam, so I guess we could also unreachable as well. So that will like exit out if that happens. If we have it, that's, and then we want to check if main thread you know what? Let's just do this. See if it's actually there or not. Okay. We do get no main thread. If we don't do unreachable, will we exit? No. Okay. We're getting forward. What do we want to look at? Maybe just which threads are alive. I'm gonna also exit immediately, so let's do like threads. Okay, so this is the ID. No, wait, that's not the ID. Items. Oh, 0 to, okay, sorry. There we go, that's the thread. Don't know what I was thinking there. So we have the thread, so no main thread. We're gonna say thread something. Okay, and then I'm gonna say the instruction. So format. Current instruction. Let's do that. Okay, so we're still on 8. That's the only thread that exists. Thread 8, stream as 1. That's one of the streaming threads. Thread 8. The thread number should stay the same if we debug this. Whoops. Thread 8. Okay, let's also do thread instruction counter. No. Private instruction counter. That should have a format function, right? No? Oh, this one. Yes. So that is instruction counter. There we go. Okay, so set 2. So that is simply a, you know, we should find it by fork 2. Oh. Fork 2. Alright, we only have 2 places where this is happening. And it could be either of these where it's happening from. I'm gonna, well, yeah, it could be either. It would be cool if we could mark a fork to have it named. That would be easier to debug as well. Although the name was, or like, which instruction was it? Where did the fork came from? That would be good to have. Thread 8. Okay, so what I want to do is I want to do set. So this is set 4 and set 5. So set 4, I want to set a breakpoint there. So breakpoint 4, was it 25? Yes. So which thread is this? Okay, that is thread 8. So it's the first thread. It's the thread for echo, I believe. So how can that happen? It's gonna be like this stage here. the pipe actually set 2 is no, that's standard out. Yeah, okay. So the standard out pipe is never, that doesn't close. Well, it probably closes for the process, but we don't. There's some race condition that makes it not close for us. So it's gonna be this pipe over here that we're creating, like here. That is keeping open, and then in like the set, we're compiling the expression, which is compiling for the executable. Hang on. So thread 8, pipe 3, right? That is the first ever pipe that is created. That is not the standard IO pipes. So that should be the first pipe. That should be the same pipe as this that we're creating here. Okay, and then that is then used when we fork. We compile expression. What is this? The stage expression that gets compiled. Oh no, actually, this fork takes that. Okay, yeah. This fork takes the pipe. Yeah. This fork is doing that. So, and then we have this set. Inner set is compiling the execution call in here, and this is now compiled with that like context. I'm just trying to map the instructions here to wherever it is. So thread 8 is spawned from set 4, which is the pipeline set, main pipeline set. Yes. Okay, and then this is actually not the pipeline set. This is the. Wait, where is it? No, the pipeline set is actually compiled directly in the original set. So the pipe is compiled in set set 0. Here's the pipe, yeah. And then we fork set 4 somewhere here. That is the first stage. And then that, so that is it's really confusing here, but it's basically, it's this thing here. The fourth set number 4 is this thing here. Here is, we're compiling the execution call, echo, and then we're looking at the result of that to see if it's waitable. We're waiting for it. We also have a push. Yeah, this is the thing that spawns the thread that doesn't exit. And it's just inheriting the thing that we have, which is already set to pipe 3 as standard out. What was this? Oh yeah, that's the set to stream standard out. Could it be? So what happens if we run through a bunch of instructions before the executable has a chance to output anything or do anything like that? The idea is then that we set keep open to false in this pipe. Actually, we could also check there if this is true. This should be true. I mean, it should be. It should actually be false. So it should be keep open false, because there's no other threads running. So this has to have gone through here. So let's go to evaluator. No, runner. And it's gonna be thread 8. So it's gonna be, so we're gonna say thread. Well, the pipe is 3, so we know the pipe. Get the pipe, and I'm gonna log pipe. I'm just gonna log like the options here. Or config. Arguments. There we go. And keep open is false. That is correct. It should be false. Okay, good. It's false. And okay. What else can we say? Well, it's constantly streaming it. You know what? Also, let's also add this thing. Let's add, I believe we can add another option when we create the pipes. And that is they have to be, so we keep open. We also, there's also another thing, complete after source closed. Oh, this is wrong. This is graph reference. So keep open and complete after source closed. So this is basically making it so that when this is true, it has to wait for a connection, and once the connection is closed, then we also close this pipe. I believe we can use that instead of keep open true, actually. I think. So actually, let's do that. Because all the, like the reason why I did it the other way is that the idea was that they could get like multiple connections, or they could get a connected and a disconnected. The source was connecting and then disconnecting, and then another source connected and then disconnected. But I think in like all cases, we actually only have like one source connecting in the case of these pipelines, and then disconnecting. If that is gonna change in the future, we have to fix it. But for now, I think maybe this would work better. Okay. We don't get anything now. Okay. Okay. No, stream. I mean, okay, what if we do verbose? Does that change? Well, now we kind of see maybe more what's happening as well. We're stuck on 9 and 8. So no streaming threads. Interesting. It's because they like prematurely close or something like that then. Okay, you know what? Let's try adding these back in so we have both of these, perhaps. I don't think that's gonna be. Probably not gonna work. Okay, well, it works for variables, but I'm not sure it's gonna work for this thread 10. Okay, so it changed the thread number, but it's still, we still only have one thread. I mean, probably because things are happening out of order now, or in another order, I should say. But this is still keep open false, complete after source close true. Yeah, so I don't know, man. For some reason this doesn't close. Does it have any data in it? Doesn't really matter though. Pipe data. No data, okay. Do you have any sources or destinations? It's probably doesn't have any sources. And destination. Equal to null. Or not equal to null. No sources, no destination. Okay. And keep open is false. So I think this is a race condition, because it's like if keep open is false, we have no sources, no destination. Normally, it should just close the pipe if this is the case. I think or maybe not actually, because it needs to wait until it has one connection at least. I don't think we have like that state. If it could be a race condition if it like completes the whole thing before it's even done anything like that. That shouldn't really happen though. That is strange. It should actually like connect something. It has to, in order for the process to close even, this has to receive data, forwarded it, and then closed whenever the source closed. But maybe I've introduced some bug here, like race condition somewhere. Because it's like, yeah, you go into forward, you see that, okay, we have a destination. If the destination closed, we also close this one. If we have data to write, we write it. If we have no sources, but we have a destination and we keep open, then we return no source. If we don't keep open, we close. But we don't have a destination, that's the thing. We don't have a destination, so we return no source. But the thing is, we could have said like, have we had a destination? So we kind of flag, we're gonna flag. Maybe we could use is completed, because I don't think we actually use this. No, we don't actually use this flag here. So let's say I mean, maybe is completed is wrong. I would like to have something that is like, it's not even used anywhere. I would like to have something called like, it's like, is this cold or hot or something like that? Like, has it been ever connected to something? Has been connected. Okay, and we start out as false. Whenever we connect it to either a source or a destination, it should get, we should set that to true. Connect source has been connected is true. Connect destination, set it to true. Okay, and then in this forward function we will do this. So if we have no sources, if we have destination, I guess, or, because we don't really need the destination, or we have been connected, then we close. Oh shit. If this is not equal to null, I'm just checking. Okay. There we go. Okay. What the hell? We got a okay, so we get like a reverse. Oh my god. So we get like a reverse race condition now. Hello, Vincent. Who are you talking to? Oh. Oh, I see. That is a good I mean, yeah. I think I'm gonna keep it like that. But that's funny. Let's see. Okay, we get reverse race condition. Oh my god. So 8 and 9. Waiting for exit handle. And 2. So it seems like the string doesn't close, and then the other things are waiting for each other probably. So I mean, there might be an edge case here somewhere. Sources is 0. I mean, we could also say, like, if keep open is false, we have been connected, but we don't have a destination, but we have sources, then we should also close. Like, if we don't have, like, here we're looping through all the sources, and we're saying, okay, well, we have stream, source result. What the hell's? Oh yeah, so we're checking their status. They might be still open or something. For example, maybe standard in. I'm not sure, but anyway, this looks at. This tries to stream something there. We get a stream, get right fail. We get some error. If we don't, we are down here. But right, so and then we get down here. We disconnect any source. So we're actually never checking. But the sources themselves should like close. So that's the thing. Like, if they don't close, maybe we shouldn't close the thing. But if the destination did close, maybe we should also close the source, actually. But that is what's happening here. It should happen here. So I'm not sure what world we're living in. I mean, I guess let's do this. Else if has been connected and not keep open. I think at this point we also close everything. But keeping open, no, it's not keep open, so there we go. There's too many edge cases there, man. It should be more generic, but oh, it still doesn't work again. That works, but this doesn't work. Okay, so let's go to the debugger and let's figure out where we could make this stop. I'm gonna say so. 9 set 9. This is fork 9. Maybe here. Where's this set? 6, 23. You're waiting for something. Right. I think we're here now, probably. Yeah. See? So let's look at the pipes. Pipe. So 3 and 4. So we have 2 pipes. This one doesn't have sources. It has a destination. And keep open is false. So this should close. I'm not sure why this isn't closing here. Complete after source close true. And then we have another pipe which still has a source and a destination, and keep open is true. So that, I mean, yeah, it's probably waiting for this to close, but for some reason that this doesn't close. Okay. Because it's like we have 0. Okay. We did have a destination, so it's going in here. Destination is not closed, I don't think. Otherwise it would have closed everything. So, and then wait, is that true? Yes. It should have closed everything. So, and then we're checking if we have buffer data. We don't. I don't think. Flush. Does that? Okay, the flush, does that actually remove the data though? Where's the V table? That's the allocating, right? I don't think that actually removes the data. But then we would get like infinite output. And I don't see any output anywhere here. Maybe we do get infinite output though. Flush. Write all. Oh wait, no, it's cleared here, right? It's cleared here. 2 on slice. Yeah. This should like remove it from the buffer writer. Yeah. All right. This is a different writer as well. Okay. Anyway, never mind. Okay. So the point that I'm trying to see if we're returning early here. And we're not. So here's like, okay, well, if you don't have a destination, well, we did have a destination, so we don't go in here. We did not have any sources, so we should go in here. And destination is not null. That is true. We should have been connected, but I'm not sure if that's true or not. And then keep open is false, so we should close at this point. So I guess this is false. It's like it's never had a source. I want to check exec. Pipe. Standard out is the thing we're looking at. Is connecting a source to this. So I mean, this should be true. Pipe data. No, print pipes. Hang on, pipe data. No, print pipes. Hang on, it's gonna be the stream format function. Label. What is this? That is the thing. Source. Where's the config? Oh, there we go. That's the config. Okay. And let's also do. Yeah, I don't think we need to do that, or we do, I guess. Yeah, it's a double pointer. So let's do like has been connected, and I wanna say has been connected. All right. Okay, now we're back. Now we don't get anything. Wait, no, 620. Where's 622? Step a bit. All right, so pipes. Has been connected true. Okay, both have has been connected true. So pipe 3. What? Hang on. Stream as 1. Oh, wait. This is wrong. No, wait. That's thread 8. Which thread are we on? 10? Where's thread 10? Wait, oh. This doesn't show the ID, it shows the index. That's wrong. Print threads. Wait, what? No, wait, I might be confusing. thread with set. Yeah, this is thread 10. That should be an ID. Yeah. And then stack. Okay, here the stack is wrong. The stack display print stack. Also, there's way too many new lines. I'll just do this. All right, so this would be yeah, here we go, thread. So this should be thread ID instead. There we go. And you don't exist. So now if we say stack, now we're getting thread. Okay, now we get two. Okay, I'll add one more. I guess I'll add this. Whatever. Okay, so thread 10. I'm gonna continue here. All right, so we got 10, 11, 9. So yeah, so thread 10 is the one we're interested in. Thread 10 has pipe 3 and 4. Okay, that means that there's no thread that is running pipe 3 anymore. For some reason, that thread is either never spawned or it's prematurely closed, or it also it didn't close the pipe properly. So okay, let's go to here. And we're gonna see if there is any edge case where we return a closed. Actually, I want to look at this is used over here. So it's like if we get a closed, it continues. Oh, you know what? I think what's also happening is like the pipes are never like cleaned up. So this pipe is like continuing. We don't like remove the pipes, but we should definitely close it though. It should be like closing itself basically. It could be that we get on the closed event, but the other pipe that it's connected to doesn't understand that this is closed. So this pipe does have like a, it has a closable, which is over here, and it never closes when you manually close it. It never closes basically. But how? Okay, so I think we're not really using this to do that. No. I'm gonna look at wherever we return closed. I think the new place we do it is over here. It's like we have a source, but it did close. So we process close ends. This should be true. We close our ends, which just closes everything. If keep open, we're not done. Otherwise, we're closed. So we should really be closing everything at this point. And then we return closed. But we never remove the source. But it should be removed if this is doing its thing. Man, okay. Close source, close destination, disconnect source, disconnect incomplete. After source, closed, keep open false. Yeah, it's okay. Maybe it's not the pipe that's the issue. Maybe it's the the process here. This process. Yeah. Okay. Okay, you know what? I don't think we have we have pipes, but I don't think we have a way to show closables like the processes. So let's actually add that. No, closables. Wait. And so you are this. Do you have a format function? No, you don't. The only thing we could do is get the label and the result. Because these are they are very generic things, so you can't really get, I mean, no, you can't really get any more information. Maybe if we stored a pointer, like a void pointer or any opaque pointer to some underlying data, but then you have to know the type before you can use it. I mean, right now we only have processes basically for this, but yeah, so this would be S is closed. Key pointer, okay. This would be get label, and then get result, which is I think unknowable. Optional T exit code in this case. Right, so it should be like this. All right. Let's try this again. Okay. We've got the first one, or yeah, the first one is actually closed because 0 means true. I mean, that's the exit code. We get the exit code. Okay. Good. But then we have the other two. Okay. And so 9. Yeah, those are not closing. I mean, I guess it could be that the standard in so okay. This pipe is the pipe between the echo and the cat, but echo is closed, so this should be closed. This thing should be closed. I think it is closed. It still has like a destination, so that's where I'm concerned. Like it has a destination, but nothing is streaming it, so I think it returned a closed event, but maybe some kind of reason why it's not actually closing itself, or okay, I need to figure this out. Stream, no, let's see, evaluator. So stream exec right. So the way this is kind of managed is from these things, the process IO, and this is closed. We also have this thing which determines if it's closed or not. So this one has a vtable close, get results is checking if we have a term on there. We do. We should have one because it was there for pipe 3. really what's missing from the debugging data is like, okay, well, it's connected to standard buff, which is really cat, I think, cat to cat. But how? But then what is the rest of the connections? How do they look? Trace. Is this even used? I don't think this is used. Oh, what happened now? No. But this is used. Yeah, okay. Yeah, we're passing a tracer everywhere, that's the thing. The tracer is like... Well, if this is on, we obviously should trace something. That basically is, it's just a logger that is toggleable, like if it's enabled or not. And it has tags where you can toggle like which tags do you want to show. If you want to trace a specific, you know, a specific feature. And this just create, and then we have like, and it also stores it in a list so that we can also like look at it in a list as well. But it also echoes it out. So I believe maybe we can even in the debugger trace. So there's a trace command. I mean, it would be cool if we could show it after the fact. We could show the entire trace as well. But I think this just toggles it on and off. And I don't remember if it's on by default or not. It's on by default. At least here. True, true. Tracer false. So the main tracer says false. And then it's just passed in somewhere here. Debug. Yeah, it's passed in here. And here we actually set it to true, so it should be true. So it should just show everything, every log. I believe that is what we see when we go continue. We see these information here. These are the trace things. So I wanna see if we go to stream here, for example, like source closed, removing source. So we go here and we search for source closed, removing source. Oh, it's cut off. Okay. I also hate that we wrap with standard buff so that we don't actually see what what are we actually, what's actually happening here. Okay, this is like, no wait. Yeah, we're streaming that. They closed. Which thread was this? I wish we showed which thread it's coming from. Actually, let's add that. So that is from, where is that happening? Print instruction. I want to see which thread this is from. So thread ID. Source closed. This is from thread 8. Okay. 8 is gone. And we also have thread 3, which I believe is the main standarder, which are like closes direct, like automatically for some reason. Okay, so that's the only two. Thread 8. Okay. So where are we? It's probably from set 4 that is happening. 423. Right, so now threads, we shouldn't have a thread 8, so we step here, now we have a fork thread 8. We look at the stack, we can see pipe 3, this is the pipe we're interested in. Okay, if we log pipes, we do have the multiple pipes. Okay, so it does have a source, it does not have a destination. Keep open is true, has been connected is true, so that makes sense. It has a source, that should be like standard, or it should be like echo, the echo thing. Okay, and where are we actually? Okay, so now let's see what's happening here. This is the thing, it's streaming. Okay, let's look at this. So it did forward, I think, hello here. We can see that the source has hung up. That was this means H up, it hung up. So there we go. Stream disconnected sources. But since it has keep open true, it didn't actually close. So now if we look at the pipes again, so let's turn off this window, pipes, we can see here that these, well, okay, the source is still there. It should have disconnected that, I think. Okay, that's weird. I guess it it disconnects it next time, because okay, this we don't actually see here what it says because it will cut off from the info window, but it did forward the thing. I think next time it will actually disconnect the source. We're at 4. Now we're at 5, 7. Well, thread 7. Now we're at thread 8. So let's see what's happening now. Okay. So now we can see, well, our event says 10. That then, I mean, yeah, this is decimal, I think. It means, no, it's hex. It's hex. 1 means 16, so that's hang up. And then we don't have any other events. Before it said 11. And 11 was for 1 was for that it actually had data. So now it didn't have data and it's closed. So we're ready to close this now. So we're closing it. Okay, the process is closing as well. The whole process closed. Stand above. It's always a stand above because we're wrapping everything in stand above. And that is echo hello that we're doing. So we're waiting for it to terminate now. This is actually a blocking thing. But it should just terminate directly. So it terminates. Success. Okay. Sources close, removing source. Sources close, closing ends. Stream disconnecting all sources. Disconnect the destination. But we're keeping it open because the keep open has not yet been turned off. So it's keeping it open. So it should not be closed at this point. It should not close. It should keep on streaming it. Okay. Where are we now? Thread 6. Thread 7. And we're still at thread 8. So let's see what's happening now. It just streams. Nothing happens. Okay. Let's look at the pipes. It's still here. We don't have a destination. Keep open is still true, so it should still like keep that going. Yeah. That's still keep open is true. It hasn't gone to that. Okay, here you can see now we set keep open to false. 1 means false. So what's happening now? Where's thread 8 is soon to be executed. Now it's executed. So what's happening now? Everything is 0. Stream disconnected all sources. Stream closed. And if we look at the pipe, now keep open is false. And this thread is then it's gonna exit later. Okay. And this pipe hasn't even connected yet. It hasn't connected to anything yet. It has been connected as false. So this thing has closed now. I think it did forward to the cat. It has forwarded to the cat. But I think maybe the problem is that the cat has not connected yet to this pipe here. But that should not be... I don't think that's an issue though. Okay, where are we now? You're exiting. And you're doing that. Okay, now I think cat is being executed. It's being launched. So now after this, the pipe should be connected. So this pipe is now connected here. We don't have a destination yet, but we do have a source. And it's going to be interesting if this source actually has like any data to read. Because it's, yeah, okay. I think this might be the issue. This pipe is like completed before the cat actually does anything. This is just the standard pipes. Standard pipes. Wait. Yeah. Oh, yeah. You're doing that. Let's do this so we can see where we are. Thread 9. Okay, you're waiting for, I think you're waiting for closable 1. That's cat. Okay. And you're still thread 9. So the issue, I think the issue okay, we have a fork. Let's look at this new thread. See, now this one has 4, so now 4 is ready to forward here. The input pipe is pipe 3 though. If we look at the data, there is data in pipe 3. So when it gets connected, I guess it will output into pipe 4. Maybe this is why it never closes. Perhaps, I don't know. Pipe 3 is connected to pipe 4 at some point. This is just streaming pipe 4. That's streaming from output of cat to this pipe. The problem though, I think, is that pipe 3, no, it has a connection. It has, but nothing is streaming it anymore. Okay. Oh, you know what? Maybe we should have this one. This should be turned off, not after. It shouldn't be turned off like immediately after the first stage. It should be turned off like at least when the destination has been like properly spawned. I think. We could even wait for after the whole pipeline has been spawned. Maybe, if we can. Man, this is so... I don't know. It's so fickle. Okay, so basically, we're gonna keep it. I'm not sure about this. I think I'll just remove this. And then this thing we're gonna wait with this here. The problem though is that we need to be able to refer to the pipe somehow, like maybe we can save them in a list or something. Where is this happening? This is happening in the stage set, yeah. So this is happening like after we wait for the process to complete. We then close the output pipe. But the problem then is that we could close this before the destination has been connected, and that's the issue. And another issue is that we don't really know when this is completed. If we're outside of this context, it gets harder to check this. We could possibly create a variable for each stage and then continuously check if they are true, to check, like do some kind of lock. And when all locks are true, like that means that now we've spawned all the executables. We can go ahead and wait. Is that what we are waiting for? Like if we go to, yeah, I think so. If we compile an executable call, we don't actually wait for this execution to run. What we're doing is we're spawning it, and we're returning the process handle. And we can choose to wait for that handle. What we're doing is we are waiting. We can choose to wait for the execution handle or the thread handle. Well, the thread does wait for the execution. So if we wait for the thread, we also wait for the execution. So there's not really anything to wait for. This is also the execution itself is happening inside another fork here. So there's actually no way to know when we've actually executed, like when we've spawned executable. Because that's where the pipes are hooked up. That's in the same instance as that. Yeah, this part here. After this instruction, that's when it has been hooked up. And that's when we actually populate this execution handle as well. So I guess one way to look at it is that we could wait for the execution handle to be populated, and then we know it has been executed, maybe. Yeah. The weird thing though, the idea was that this would not really connect to a destination before the next, like the idea was that the next executable would be spawned, then this gets connected to that. So really there should be no issue in doing it like this. But I want to go through this again. I might have missed something here. 423. So this spawns the thing that is streaming pipe 3. So pipes. Yeah, it doesn't have a destination. Okay, so at this point, it's like it's in a mode where it's reading from this and storing it in its buffer. So it shouldn't actually close until it's connected. And this one is false, so it really should still keep open. Yeah, here it receives data, so that's stored in memory. And it shouldn't close. Yeah, this was even empty, so it didn't even disconnect at this point. Now it's keeping open because it didn't have a destination. Well, no, it's keeping open because it has to keep open set to true. But it did disconnect everything, although it didn't have a destination anyway. So now it has destination 0, sources 0. Now there could be a weird race condition there where it lands just right and it like disconnects the destination before keep open is true or false, I mean. But then it should actually just disconnect because has been connected is true at that point, I think. Let's just see what's gonna happen here. Okay, now this says nothing. Next time, it's done. For some reason now it's done. Thread 8, it's keeping open. So if we look at the information now, it doesn't have a destination, doesn't have sources, it has been connected, keep open is still true. Still true. So this shouldn't do anything, this should just say that this shouldn't really do anything actually. It should just see that okay, you don't have a destination, don't have sources, so we get a no sources. It should keep open. I'm just gonna make sure this is true. So we go in here, we don't have a destination, we have been connected, and we should keep open, so we shouldn't go in here. This didn't trace out. We don't have any sources, so it should actually log this. I'm not sure why this didn't log out. That's strange. Unless we received a closed... this might be the case. So we could have received a closed event before, but that shouldn't happen if we... Okay, so we might have gotten here. And then in here we might have gotten that the source is closed, right? And we're removing the sources. Yes. I think that was what it said. We got the event stuff. This is get result. We are closing. Oh. You know what? I think there's a side effect to call get result. I think that might be what's happening. It's closing the thing, but we should still, you know, we should still have the data, so that's fine. And then this exits sources close, source close, removing source, sources close, removing closing ends, source close, removing source, sources close, closing ends. This is what's happening. Fully connected is false. We're closing ends. That's fine. So if keep open is true, this is true. It says keeping open, return not done. So it shouldn't close. That's the whole thing. It should not close the thing. But this is an event that's returned here, and then we switch on that. And if it's not done, we should return not done. Huh. Okay. Then I am more confused actually, because keeping open and then it should return not done. But then next time you're actually okay. Yeah, okay, so 8 is still there. Okay, 8 is still there, but the weird thing is that this didn't output anything at all. That's the weird thing. Like, it should have gone in here. Oh wait, we're using log and not trace. I see. What? Fine. Yeah, these are the tags. Actually, I mean, yeah, fine. This is the entry point. All right. And then the other one. These are the tags. No source connected. Okay, well, let's just have this there. No source connected. Yeah. Okay, so we should be seeing this function, or I mean this output. There we go. Okay, so let's redo this here. Oops. Oh. Okay, there we go. There's the 8. And keeping open. Now we should see. Okay, there is a forward no source connected. Okay, that's what I was expecting to see. No source connected, right? So we're in here. We don't have a destination. We have been connected. And well, if we look at the pipe information, we can see that we have been connected. Keep open though is true. So we have been connected, but keep open is true. So we should just return no source. which I believe we should, that's what's happened. Okay, good. Yes, because we don't have sources. Yeah, no source connected. Is that what it said? No source connected, yes. So next time around, should still be on that instruction. Right? And it still says forward, no source connected. All this is still true. At some point here, now the keep open is false though. And this is where things go wrong, I think, because it's gonna see, it's gonna go in here now. So it's gonna see that, okay, we don't have a destination, so we're going in this branch and we have been connected and we're not keeping open, and now we decide to close everything. So this is where things go wrong here. Okay. So we basically, we want to wait for a connection. I mean, if we wait, so we want to wait for a connection and then make sure it's disconnecting. There's another scenario though. So let's say we're waiting for a connection and then disconnecting after that. But what if we already connected a destination? We already forwarded data. Everything now has been disconnected and keep open is turned off. What should happen now? Because now we should be closing it. I guess maybe we need like has been connected for both ends. Like has source been connected, has destination been connected. Or maybe this should only be for destination actually. Maybe this only is true for destination. Right? It feels very fickle, this whole stream thing, but okay, I want to try two things here. I want to try just running this. Okay, it works just running. What about verbose? That also works. So problem solved. No, but yeah, okay, well, I proved it works now. But there still could be technically a race condition in there somewhere, but it does work. I guess we'll have to see. Time will tell. Cool. So now both the verbose, that works, that doesn't hang, and this works. Oh my god. Okay. Wow, so pipelines work again. Woohoo! Now I want to check. Well, of course this should work. Yeah. So pipeline basic bindings basic. This. Oh my god! Now this doesn't work. Wait. Okay. Yeah. Let's remove that. Where was that runner? Let's just remove. Where was that happening? No. Here. This one, yeah. So if No, so basically all of this we return. I forgot what it was. Can you do this? No. There's probably some way you can do that. Where is that happening? Continue. Okay. Okay, now we're hanging here. I mean, okay, so there still is some issues here. Okay, so this is different. This is like... Actually, this is kind of weird. We're just, I mean, we're just doing this, right? So it should be the same as basic. Almost. Except we're dealing with... I'm not sure actually. Where are things happening? Fork, this one, so fork 4. That's the whole thing. Wait. Oh, this is just doing that, okay. Five is spawning the thing, I think. Yeah. Okay. There's fork 4. Or there's fork 4. Comment. Alright, that just set, you know, a thing on the heap. So heap, I don't really know where it is. So 13, yeah. And we're waiting for something. You're done? I think we're waiting for 4, yeah. So we're continuing, some comments, comments. It should really skip all the comments. I should add that as a thing. Execution else, now we're getting ready to spawn the execution fork. There's the closure. Setting some variables on the closure. There's the fork. So we're still streaming this pipe here, this pipe 3, which really doesn't actually go anywhere. It was just a context for the binding, which really didn't require a context because we didn't have anything pushing to standard out or reading from standard in. It was just a constant, as you can see here, hello world. So this, because we have a binding here, this is ran in a context with its own pipe as standard out and all that, standard error. So I think these two threads, 4 and 5, they should have already been like done. They should have been executed, or yeah, they should be deleted basically. I think that was the behavior from before, because we have a binding now. So if we go to the I think that's the case. So if we go to the compiler, compile binding, and we go to identifier. So this is compiled. We're creating we're creating 2 pipes here, standard out, standard error, and then we're compiling something. We're forking those, and we're compiling with the context with these pipes. It's not really needed if the result here is just a comp time known value, but we don't know that beforehand. So we're doing this in preparation for it if this was compiled with, you know, if it needed to be stored, if we have an echo something or something like that, then we need these pipes to catch that information. If we don't, then it's just going to output to the inherited standard out. But we're trying to bind. But if this is like a comp time known value, we don't really need these pipes, but we always have them anyway. So, and then we set the option here, complete after source closed. I think actually after this is done, maybe we can check if, because these pipes are never connected, so they will like if keep open was false, it is false here, but this is true, so I think this trumps that in the scenario where we if we don't have sources, no, then we just return no source, because there are no sources. They're never gonna get connected basically, and so they will just short out here. That's the issue. Maybe we could have these pipes, man. Maybe we could do like inspect this to see, okay, well, are you a runtime known value or not? If you are, or I mean a comp time known value. If you're a comp time known value, that basically means that we don't need these pipes. These pipes are never going to connected. I mean, even if it's a runtime value, they might never get connected anyway. So it's kind of weird. How would we know if they are gonna get connected or not? Because they are kind of waiting to be connected before they close, and these threads are gonna keep on forwarding them until end of time. So it's like we don't know if this is connecting them or not. And we don't know if it's connecting them, well, yeah, we don't know if it's connecting them like in a fork, which happens like after these instructions have been ran. Maybe we could include in the result if it has used the pipes or not. Man, it just gets so complicated. I mean, the best thing is if we could do as the closure variables, like, because they are it's like a conditional compilation. It's like we don't compile it unless we need it. It could be the same thing here. It's like, okay, well, if you need standard out, standard error, we compile it. We kind of insert these before and give you those things after the fact. Because, yeah, it's like this fork is using this ref, this fork is using this. So I mean, all of these fork doesn't need to be there anyway. So I guess these things, all of this could be conditionally compiled depending on if this needs it or not. All right, I think I'm gonna have to sleep on this a little bit. I'm gonna add a to-do here. Issue here when the result is not connecting the pipes, causing it to never close the pipes. Maybe we can have them be conditionally compiled if the compilation of the expression requires pipes. I think that's good because it can be used for other things as well. Like if we have a more generic way of, hey, this compilation actually requires something, maybe standard in, maybe a function that doesn't reference standard in, doesn't actually care about standard in. You know, it doesn't actually have standard in. So then we can also infer that the standard in type would be void for that function, for example. So yeah, that would be cool. Like you can have inferred like did this compilation require standard in, standard error, whatever it needed, and then we'll add those things after the fact. The only problem there is like, well, one problem is now we have to add that information. We have to make sure that everything is up to date with that new fit thing. Also, when we insert this would actually affect the compilation. This would affect the relative stack counter of this thing here. So maybe we need a more robust way of handling the relative stack counter as well. It could be that you have groups of compilation units that has their own relative stack counters, maybe. Something like that. We'll see. Right now I have a stack of stack frames, a stack of stack frames, where we can, you know, have one compilation unit have correct relative stack numbers. It's just that it's not really used like that now, where we can have them in this. Like they are only used right now for different forks. They're used in a very special way, so it's not possible right now, I don't think, to have that. But that would be one way of also fixing that issue. But this is the main issue for this part. And so it's like, okay, we'll check after. Does this require, maybe it's going to be part of compile with context. I'm not sure, but does this require like pipes? Okay, then we'll add these things as well, and then provide them to this context here. Because this does a lot of things. We have a new instruction set, we have a result variable, we're grabbing all this, the context here, we're actually creating a closure and a fork and all that. So it's doing like a lot of things, and these things are not really needed if the result, none of this is actually needed if the result actually doesn't need a different context. So actually this could also be part of that. All this could be part of that functionality as well. I'm gonna add that compile with context also should be dependent on this information, and if pipes are not needed, we should only use compile expression directly without a special context. All right. Okay. But I think it's a big decision here. I think it's good to make this system more robust, because right now it feels very hacky in a lot of places. And yeah, the way I'm trying to solve some of these issues is like duct taping a lot. So I feel like maybe it's time to kind of look back and try to get a more robust functioning compilation here, compilation context and all that. So but yeah, it requires a little bit of thinking and planning here. So I'm gonna sleep on this and see if I come up with any more solutions before I actually commit to doing anything with that. But the problem is clear. It's just a solution. Maybe I can come up with a more simple solution which doesn't require as much, you know, incisions. What do you call it? Operations. Okay. Well, anyway, that's gonna be it for this time. I need to eat and stuff. So thank you very much for joining me here and watching, and I hope you